Hey everybody, welcome back to Advanced Swift 3. I'm Ray Fix, and in this section we'll be talking about custom collections. Now going back to our collection protocols, this time we're going to be focusing in on collection, bidirectional collection, and random access collection. And the thing that collections give over sequences is they give a concept of a start and end index. These index can be of any type. Sometimes they're integers, or sometimes they're something more fancy. And it allows you to go through the collection multiple times repeatedly and get back to the same element. That's not guaranteed with sequences, but this guarantee is added with collections. Now, there are a couple of performance considerations you need to have when making a custom collection. One of those is that a subscript should be a constant time operation, and that lets something like forward and bidirectional collections implement count as an order n or linear time operation. Let's see more of that in a demo.
Let's look at Swift collection types. So collections are inherit from sequences. And so you might think, wow, these are going to be complicated. But in some ways, collections are easier to work with or create. Custom collections are easier to create than sequences are because you don't have that extra iterator and next element that you have to implement. So let's start off by implementing the FizzBuzz collection. So FizzBuzz is this thing that's used, I guess, at job interviews where you loop from 1 to 100 and it prints fizz for multiples of 3 and buzz for multiples of 5 and FizzBuzz when they're multiples of both. So to start off with, let's create a struct called FizzBuzz and we'll make this conform to collection. And when we do this, there's 4 things that we need to do. We need a start and end index, and we have to decide what their type is. Now, the type is easy here. It's going to be probably good to be an int. So the start index is an int. And the start of FizzBuzz begins at 1. So we're going to actually just return 1 here. It's not going to be 0 based. And then we return an end index. And that is going to be returning 101 because it's 1 past the last element. And the reason for that is that you want it to be 1 past because if end index and start index are equal, then you know you have an empty index. It's easy to tell if you have an empty thing. The next thing that we need to do is implement an index operation, which advances our index. So in the forward direction. So index, it's going to take after. So this is just going to return a new index. So for an integer, it's pretty easy. You just say, in this case, I plus 1. And finally, you need to create the subscript. So I'm going to make a subscript for FizzBuzz here. Now I want to make sure that the position is in the indices range. So I'm going to make a precondition. So this is just a check to make sure we're good. And now we have to return the right thing. And I'll use the Swift pattern matching to do that with a switch statement. So that implements our collection. Let's instantiate one of these things. And now since we have a collection, we can do all kinds of things with it. Like we can make it enumerated, and then we can filter things like filter, say, on element being buzz. Let's look at all the buzzes. And then maybe even map the offset. Now this is an offset. That's a pitfall of using enumerated. This is not the index. It returns a offset and the value, or the element, the offset and element of the things that it's iterating on. So in order to get back to the FizzBuzz index, we need to add 1 back to it. So if we were to look at FizzBuzz, we can see that we have all these buzzes that we've filtered are 10, 20, etc. Now, one thing that might be interesting to look at is what the collection. So we just have a forward iterating collection. All it knows how to do is go through and look at these in the forward order. So let me comment this out for a second. And I'm going to put a print in here. Let's just print the position out that's being fetched. So if I create a FizzBuzz, let's say I do a reverse. We can see what's going to happen is it has to go all the way through to the front in order to get the last one. So if I just wanted to get the first 3 of those things, it has to run and go all the way through to the last one, because all it knows how to do is go forward, because we are conforming to collection. What if we conform to bidirectional collection? So now we are trying to conform to bidirectional collection, but we have to implement another method, and that method is index before. This is so it knows how to go backwards. And not surprisingly, this is just I less than 1. So when I do this, notice that it is being lazy for me here. And so I'm going to actually say, so notice now it's being lazy, and it doesn't have to start from the beginning. It can start at the end and go backwards and get at the stuff more directly. So by giving it more capability, the algorithm that it uses for reverse gets smarter, because there's different versions of reversed that utilize what type of collection it is. Now we could go all the way to random access collection. And this just says that, hey, I'm allowed to call position with anything. And again, some algorithms might be more efficient with that. All right, so this is a toy example. Now I'd like to look at a more involved example. So in the playground, there's a page called 2D array. And you'll see that a 2D array is assigned here. Now, this 2D array has an element type, and it is a random access collection, and it's a mutable collection. The difference here, or one of the main differences here, is underneath it's using a normal array with a certain width and height, but it's using a custom index type. Instead of having an integer for its index, it has a custom type that has an X and a Y, and this is comparable, and it's able to go through. So it starts at 0.00 and it goes all the way, sort of typewriter style, through the X's and incrementing 1 Y at a time. So I guess that is row major. So it goes in row major order, and it has an index before. And notice it has to take into account the width of the image. And this is why the index update methods are part of the collection itself, is because in this case, think about it, you couldn't update the index all by itself without knowing the width of the thing that it was indexing over, so that it could go to the next line. Now there's a subscript operation here that gets at the actual storage, and there's both a setter and getter, and that lets us be a mutable collection. If we don't invalidate the index types when we mutate the method, we can be a mutable collection. There are actually not that many mutable collections in Swift. Dictionary is not a mutable collection because if you mutate it, it might change the internal hash table. Whereas an array is a mutable collection, and our 2D array here is a mutable collection. Here's an example of that. We're initializing it and then poking in a value 13 into our array here. So in the challenge, you'll look at creating some iterators that iterate over rows and columns of this 2D array. All right, I hope this gives you a good understanding of collection types in Swift and how powerful they are.
Well, that's it for this video, and as always, we like to leave you with a challenge. In this challenge, given the 2D collection, you're going to implement row and column methods that return in any sequence type that let you zip through the elements in that row or column. Thank you for watching. I hope you've enjoyed this video, and we'll see you in the next one.